A brief introduction to functions. Before continuing with exponential graphs, first, we have to anticipate the definition of a function in mathematics. We will deal with this concept more extensively in Chapter 16 of this course. A function is a one-to-one relationship between each term of the independent variable set, usually denoted by x, to the corresponding terms of the dependent variable set, usually denoted by y. This one-to-one relationship is often given by a formula, but in many cases, it is shown graphically through the graph's line. It is worth stressing here that an element of the dependent variable set may two or more different values have in correspondence from the independent variable set, and this relationship is still a function, but the reverse is not allowed in functions. In simpler words, a y value may have two or more x values in correspondence. For example, in the function y equals x squared, where the value y equals 9 has two x values in correspondence, x equals -3 and x equals 3, but the reverse cannot happen, or if this happens, that kind of relationship between the x and y values is not a function. For example, y squared equals x minus 1 is not a function, as for a single x value, for example x equals 5, we obtain two corresponding y values, y equals -2 and x equals 2. The equations discussed in Chapter 9 may or may not represent functions, depending on the type of correspondence their variables have. The graph of a function shows the line that contains all the possible combinations between the x values and the corresponding y values of that function. Depending on the formula of the function, the graph may be a straight line, in linear functions, a parabola, in quadratic functions, a hyperbola, in the inverse functions, i.e. in functions of the form y equals k over x, and so on. Exponential and logarithmic functions have their corresponding graphs too, which we will discuss later on this tutorial. A good method to check whether a given graph represents a function or not is to draw a vertical line in the sections where you have doubts that an x value may have two or more y values in correspondence. If the vertical line intercepts the graph at more than one point, that graph does not represent a function. Look at the figure, where the graphs of the lines, equations, x squared minus y equals 3 and x minus y squared equals 1 are shown. We have the following shown on screen. Figure A, which represents the line x squared minus y equals 3, shows a function, as all values of the independent variable set, x values, have a single y value, dependent variable, in correspondence. This is easy to confirm, as if you draw a vertical line from any position, it will intercept the graph at one point at maximum. On the other hand, figure B, which represents the line x minus y squared equals 1, does not show a function, as you can easily find x values that have two y values in correspondence by drawing vertical lines. Thus, if you draw the vertical line x equals 2, it will intercept the graph in 2 points with y coordinates y equals -1 and y equals 1 respectively. We denote a function by y, x, f, x, etc., but in this tutorial, we will use the first notation, for example, y, x, equals 3x minus 1, y, x, equals x squared minus 2x plus 7, etc. The variable in brackets shows the independent variable. We read the notation y, x, as the set of dependent variables y that are in function of the corresponding independent variables x. That is all for lesson 13.3.1. To continue this tutorial, please watch 13.3.2, Exponential Function Graphs. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.com.